I've been thinking about this, and I think there is no real way to make this this part easy peasy lemon squeezy. I'm going to go through the code and what it does for our good dog that has both bark and working ears. And then your assignment is going to be, I'm going to give you a link to this code. And your assignment is going to be to fork it. So when you see that, when you click on this, you can click fork and you can make your own copy. And what I want you to do is break it and play with it. You can always come back. If you totally have yours totally messed up, you can come back, click on this, and fork it again to get a fresh new copy that works. And I want you to make it do some new stuff or do anything that that you like. Just so I want you to work through it and make sure that you've understood kind of where you think everything is working. Okay, we just as before, we have require observer. So that's going to bring in all of our observer functions that are going to make bark and those other things work. I'm going to add a global variable. This is how you add a global variable in Ruby, and I'm going to set it to 0. So I'm going to initialize it to 0 here. This is the same as in Scratch when you make a new variable and you say make it for all sprites or just this sprite. This variable is for all objects. All objects can have access to this variable. But if you look inside the class bark, this variable can only be accessed by bark unless we have this magic Simon Says to get to it. Okay, so this is a global variable, and we're going to need to limit the times the dogs have barked because otherwise this will go off into la la land and won't come back to us with how many barks and things as the dogs just respond to each other forever. So it's going to kick back out, and we need to count how many times they've barked. All right, so I found that I needed to add this to our bark, and that is to get just the sound out of the bark. Sometimes I'm going to need just the sound. Before I had bark now to give me the sound, but bark now has changed a bit. So every time I go through bark now, I'm going to add 1 to the number of times the dogs have barked. I'm going to print out this statement so I can keep track of the number of times the dogs have barked. And I have to use this instead of an @ symbol. I use this $ symbol because this is a global variable. So I'm going to use that $ symbol. It's happening outside the object. Then I have some control flow. We're back to some control flow inside this bark now. If the times the dogs have barked is less than 10, then I'm going to turn to changed and I'm going to notify observers of self. We're going to see some interesting behavior because it's not always going to stop at 10. There's some interesting theory about that. Okay, inside ears. This is the old stuff we had for ears. And then last thing, we added an update. Now I've added this sensitivity. I'm using the control flow of my sensitivity. If my sensitivity is greater than 2, I'm going to say my name and I hear barking and I'm going to bark. And when I bark, I'm going to do my bark now. Now notice my bark dot bark now. How did I get a my bark in there? Well, when I define my ears now, I'm sending in an object, which is my bark. This is where it's just going to be confusing until you play with it for a little while. It all comes together in class dog. I initialize class dog, and class dog has a name that comes in from here. This is a string when we initialize it, and my bark is actually an object, which is an object of class bark, and it takes that string in and does stuff with it. But it turns my bark from now on is an object after we do that inside good dog. And then ears don't have anything that come in. The way we set the ears sensitivity, which is the first thing they take in, which is right here, we set the ear sensitivity, we use this random function, okay? We're going to send in the name of the dog because that's kind of easy. So we take this name and we send it into the ears, because when the ears are going to use that name. And we're also going to send the whole object. So not only did objects have objects, now I'm using a whole object inside a function. I'm having a function and I'm sending an object in there, and we'll see how that works. Oh, well, let's go back and see how that works. So, oh, let's go down here and we'll see how that works, I guess. Okay, so there's name, get name, ear check. Those are the same. Okay. So when I get the speak command, I print out my name and I say my bark, just my sound, and then I do my bark, bark now. Okay, so let's go up to my bark, bark now. And my bark, bark now is going to notify observers, and my observer, doo, 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 is going to be my ears. And when my ears get the update, they need to go to the bark object. If they are sensitive enough to hear it, they're going to go to the bark object and also call bark now. That's why we needed the thing to limit it to 10. Okay. Let's go back up here. Okay. So let's look at how we do this. So the first thing we do is we make 3 dogs. Sparky, he just needs a name and a bark. Fred and Ed. And then I print out some things, ear check, just so you can see the sensitivity, because sometimes they'll bark and sometimes they won't, and if they're not sensitive enough, you don't want them to bark, so you don't want to be worried about that. All right. When I call the function fred.earcheck after I've made him a good dog, it returns to me this is a function call. This could be by itself on its own line, but we're going to put it right here. What this gives you is the ears for Fred. So this says Sparky has a function called getBark, which is going to return something that has a function, because getBark returns a bark, that has a function called addObserver. And I want you to add Fred's ears to Sparky's bark. I know, very confusing. Ed, same thing. We need to get Ed's bark, and Ed's bark has a function called addObserver, and I want you to add Fred's ears as an observer to Ed's bark. So Fred can hear Sparky and Ed. We do the same for the other guys. Now notice I didn't make it, sometimes puppies, they can be really, oh, this is, I'm gonna have to go to the main window so you guys can see this because it won't come down. Okay, so we're just defining, we're down here, we've already made our good dogs. We created them here. Now we're letting Fred can hear Sparky and Ed. Ed can hear Sparky and Fred. Here's how we do that. Sparky can hear Ed and Fred. So there's how we do that. Now the first thing we do, and the only thing we're going to tell them to do after we add all those observers, is we're just going to say Sparky speak. See how it goes. Okay. I think I have to hit edit so I can ID1 it. Let's run it. Okay, it prints out the ear check. Nobody's over 2. So only Sparky woofs, and the number of times the dog's barked is 1. Let's try it again. See what we get for our sensitivity. Oh, that was the last time. Let's see. Oh, so we had Ed's sensitivity was 3. Sparky woofed. Ed says, I hear barking, arf. Times dogs have barked was 2. If we keep going, and I encourage you guys to do this, you will get some times, like this where they just keep going and going and going. And they will go higher than 10, and that has to do with these objects are getting notified, and then they're coming back and they're all trying to change that one variable. And the handler behind the scenes with Ruby is out of control. So the ability to update times dogs have changed is a little bit out of control. So it's not being forced to go through and check that quite as consistently because we have behind the scenes. Remember, I said that the computer itself gets to decide unless we can pass all the way through and very meticulously say, here's which object is in front to get that, and here's how we update it. Unless we lock that down ourselves as programmers, we're going to get some things like this where it should have gone up to 10, but it goes a little bit past because of how Ruby is doing things behind the scenes. But I'm happy with this. It's working. It's so I don't need to go to the extra steps of really locking that down. But it does point to you why we would want to use a procedural language versus an object-oriented language, because you're going to have some stuff like this happening in object-oriented languages. If this was a mission critical task in a pacemaker, we don't want anything extra going on. Okay, there are ways to limit this with better programming within the object-oriented stuff, but I think this is a good example to point out to you. Here we have unexpected but acceptable results. We're going to keep it. We're not going to improve this code. We're good to go with it. But in other applications, we want to choose a different language. All right, thanks. Bye.